Okay, good day everyone and welcome to today's tutorial. Before us here is a very beautiful question on limits. So today we will be looking at a limit of functions, precisely trigonometric function. So the question reads, limit x as s tends to 0 of sine 5x all over what? X. Before we provide solution to this, you should recall that limit of as s tends to what? 0 of what? Sine x over x is equal to 1. So there is this limit identity for sine x, so which is limit as x, limiting value of this function as s tends to 0 of what? Sine x over x is equal to what? 1. So whatever we are going to do now, we are going to make sure that we transform this now to look like that. So how do we do so? So let's go. We have s tends to 0 of sine 5s all over what? X. What we do now, we have to make sure that we change this one to maintain what? Parity. So let us look at algebraic manipulation. But there is another method that you can use, which is very, very simple. That one is what? L'Hospital's rule. That one is very simple and straightforward. But let me use the other algebraic manipulation. What you do now, let's also for a way to make this x here to have what? 5x. So what do we do so? So we have to what? Multiply up and down. Multiply up and down. Multiply up and down. Up and down by what? 5. What does that mean? I'm going to multiply this up, multiply it down by 5. My interest is to make this x to have what? 5x. So that at the end of the day, when I carry out my algebraic manipulation, I am going to have it to look like this, so that it will become sine x over what? X, to give us the identity, which is what? 1. So what do I do now? At the end of the day, I am going to have your limiting function x tends to 0 sine 5x all over s times 5 over what? 5. So at the end of the day, I am going to have like this limiting function s tends to 0 become 5 multiplied sine 5x, you go 5 sine 5s all over what? 5x. So as you can see, the limit becomes like this. So now remember that law of limit. This one is a constant. It can go outside. So to become 5 limiting function s tends to 0, we have sine 5x all over what? 5x. So here, without wasting much time, I can take this one to be like this. But if I don't want to make it look like that, I can say let y equal to 5x. Meaning that the whole of this 5s will become what? Y. So what am I trying to do? Let's go. Now, at the end of the day, let's continue from this way. At the end of the day, I am going to have my, it will now become 5 now, this 5 that is here. Limit function s tends to 0. We have what? We now have what? It will now become y, because here now we are not going to represent, yeah, since we already said that what? Let 5y, so here becomes y. So it becomes what? Y. So at the end of the day, this 5s now is now what? Become what? Sine y all over what? Y, because we said let y equal to what? 5x. So it means what? We have changed the function of x now to become what? That of y. So in this case here, we are not going to put s again. So in this place now, we are going to find the limiting value of this sine y, since we said that y is equal to 5x. So my interest is to make it look like this general what? Identity for sine x. So at the end of the day, we're going to have. So remember that I said that sine of that angle all over that same value is equal to what? 1. So the whole of this place now become what? 1. So putting this 0 there. So now it now become what? 5 times 1. So finally our answer is equal to what? 5. So 5 is the solution to this question. So if you find this class very interesting, please do not hesitate to share this video. As you do so, God will bless you. Bye.